Now here I am to explain the nth derivative of the function y is equal to 1 upon 1 minus 5x plus 6x square, which may also be written as 1 upon 6x square minus 5x plus 1, which may be factorized in the denominator as 6x square minus 2x minus 3 plus minus 3x plus 1. So taking 2x out of common out of these two, we have 2x in the bracket 3x minus 1, and out of the last two terms we may take minus 1 common, leaving 3x minus 1 in the bracket. And in the next step, taking 3x minus 1 common out of these two terms, we have 2x minus 1 in the other bracket, so let it be 1. Now we use partial fraction, so we assume 1 upon 3x minus 1, 2x minus 1 is equal to a upon 3x minus 1 plus b upon 2x minus 1. So taking LCM, 3x minus 1, 2x minus 1 in the numerator, we have a into 2x minus 1 plus b 3x minus 1. Comparing the numerators on both sides, we have 1 is equal to a 2x minus 1 plus b 3x minus 1. So if x is equal to 1 upon 3, we get 1 is equal to a 2 upon 3 minus 1 plus 0, because 3 into 1 upon 3 becomes 1, 1 minus 1 becomes 0. So by this expression we get minus 1 upon 3, a is equal to 1 or a is equal to minus 3. In the next step, we substitute x is equal to half in order to find the value of b. So substituting x is equal to half in this expression, we get 2x minus 1 0, because 2 into half is 1, 1 minus 1 0, and here b, and 3 into half 3 by 2 minus 1, so we get half b is equal to 1 or b is equal to 2. Now putting the values of a and b in equation number 2, we get 1 upon 3x minus 1 into 2x minus 1 is equal to a is equal to minus 3. So we substitute here, we get minus 3 upon 3x minus 1, and putting b is equal to 2 here in this term, we get plus 2 upon 2x minus 1. So writing this term first and this is later, we may write 2 upon 2x minus 1 minus 3 upon 3x minus 1. Now let's go to the next step. So we get ultimately we get y is equal to 1 upon 1 minus 5x plus 6x square can be written as y is equal to 2 upon 2x minus 1 minus 3 upon 3x minus 1, which may also be written as 2x minus 1 raised to the power minus 1 minus 3x minus 1 raised to the power minus 1. So now differentiating with respect to x, we get y1 is equal to 2 minus 1 into 2x minus 1 raised to the power minus 2 minus 3 into minus 1 into 3 into 3x minus 1 raised to the power minus 2. So we will write it as y1 is equal to minus 1, 2 into 2, 2 square, and 2x minus 1 raised to the power minus 2, and minus into minus 1, 3 square, 3x minus 1 raised to the power minus 2. Differentiating again with respect to x, we get y2 is equal to minus 1 into minus 2 to 2 cube to 2x minus 1 raised to the power minus 3 minus minus 1 into minus 2 into 3 cube 3x minus 1 raised to the power minus 3. So we may write it as y2 is equal to minus 1 whole square, and 1 into 2 can be written as factorial 2, and 2 cube 2x minus 1 raised to the power minus 3 minus 1 into minus 1 minus 1 whole square, 1 into 2 we may write factorial 2, 3 cube 3x minus 1 whole raised to the power minus 3. Now next, differentiating again, with respect to x, we get y3, 1 more minus 1 from the power we get, so we have minus 1 whole cube, and now factorial 2 becomes factorial 3 because we get factorial 2 into 3 by differentiating, so factorial 3, and 1 more 2 comes out of it because of using chain rule. We get 1 more 2, so it becomes 2 raised to the power 4, 2x minus 1 whole raised to the power minus 4 minus 1 whole raised to the power 3 factorial 3 raised to the power 4 and 3x minus 1 raised to the power minus 4. Similarly, y4 is equal to minus 1 raised to the power 4 factorial 4, 2 raised to the power 5, 2x minus 1 raised to the power minus 5 minus 1 raised to the power 4 factorial 4, 3 raised to the power 5 and 3x minus 1 raised to the power minus 5, and so on. Now let us take the analogy. We observe y1. There is in y1 the power of minus 1 is 1, in y2 the power of minus 1 is 2, in y3 the power of minus 1 is 3, in y4 minus 1 raised to the power 4. So in yn the power of minus 1 in the first term must be n. Now in first the power of 2 in the first term is 2. The power of 2 in the first term is 2. The power of 2 in the second differential, the power of 2 in the first term is 3. In third differential, the power of 2 is 4. In fourth term, power of 2 is 5. That means the power of 5 is the successor of the order of the differential. So in this way we can conclude that there must be before taking the analogy of power, we must take the analogy of the factorial. In y2 there is factorial 2, in y3 there is factorial 3, and in y4 there is factorial 4. So in yn there must be factorial n. And as we have shown that power exponent of 2 is the successor of the order of the differential. So in nth derivative there must be 2 raised to the power n plus 1, the successor of n. Now let us take the analogy of the bracket 2x minus 1. Its power is minus 2 in the first differential, minus 3 in the second differential, minus 4 in the third differential, and minus 5 in the fourth differential. That is, the power of 2x minus 1 bracket is the negative of the successor of the order of the differential. So in nth derivative it must be 2x minus 1 raised to the power minus n plus 1. So now take the analogy in the second term. Similarly, in the second term, if we observe, the power of minus 1 is 1 in first differential, power of minus 1 is 2 in the second differential, power of minus 1 is 3 in the third differential, power of minus 1 is 4 in the fourth differential. So in the nth differential, the power of minus 1 must be n. And similarly, there will be factorial n, and the power of 3 must be n plus 1, as we have taken the analogy in the case of the exponent of 2. You can understand it better. There is no need to explain for 3. So the power of the bracket 3x minus 1 is minus n plus 1. So ultimately yn. Now we see in the next step, we take the common out of these two terms. So what is common? There is minus 1 raised to the power n is common, factorial n common out of both the terms, and in the bracket what is left? 2 raised to the power n plus 1, and we may take this, we may write at 2x minus 1 raised to the power minus n plus 1 as 1 upon 2x minus 1 raised to the power n plus 1. So 2 raised to the power n plus 1 upon 2x minus 1 raised to the power n plus 1 minus, because we have taken minus 1 raised to the power n factorial n common, so what is left? 3 raised to the power n plus 1, and we may write 3x minus 1 raised to the power minus n plus 1 in the denominator as 3x minus 1 raised to the power n plus 1. So this is the required differential of the function y is equal to 1 upon 1 minus 5x plus 6x square. So this is how we calculate the nth derivative of a function of this form.